Assalamu alaikum. Now just consider two more examples on double integrals. Okay, and we explained everything, but I will give you two more examples. Okay. The first example, evaluate the double integral. Okay, e power x squared dx dy. Okay. Here, the situation seems to be easy because now you didn't need to set up the limits of integration. The limits are there. Okay, so in that case, what you should do, just go and integrate. Okay, so I go and integrate the inner. Okay, but I notice the integral of e power x squared dx. Well, how to integrate this one? This one I cannot integrate. Okay, we cannot integrate e power x squared dx. Okay, we cannot integrate this one. This is not a simple function. Okay, if you recall in Math 102, you can do this by power series. Okay, because the power is x squared. So really there is no function, simple function whose derivative is e power x squared. So what do you do here? You can't integrate. In fact, it is impossible. Okay. So if you cannot integrate, what do you do? What do you do here? Okay. So this is the tricky question I promised you, or I mentioned in the lecture. Okay. Now you cannot integrate this one. No one knows how to integrate this one. Okay. I.e., there is no simple function whose derivative is e power x squared. So how to do this and how to evaluate the overall and the whole integral? Here we do a trick. What is the trick? A trick. Okay. Reverse the order of integration. Reverse the order of integration. I.e. here, if you have a dx, what is dA? Dx, dy in the problem. Okay. Now change it to dy dx. Okay. Change it to dy dx. Okay. What does this mean? Okay. Does this mean you say, for example, this is equals well 1 minus y over 4 to 1 0 to 4 e power x squared dy dx. When you reverse dy dx, you reverse the integral. Does this what you mean by reverse the order of integration? No. Okay. No. Okay. Because remember, always the outer have to be constant. The limits of the outer integral have to be constant. Here, when you reverse, you didn't get constant at the end. But this is not correct. Okay. So what do you mean by reverse the order of integration? It means change it from one type to another. So dx dy, this is type 2. Type 2. Change it to dy dx, type 1. Or هنا the outer integral, the outer limits is the y, is a y interval, an interval in the y-axis. To reverse it, make the outer to be an interval on the x-axis, the x interval. This is what we mean by reversing the order of integration. So how to do the reversing? You start with the region. What is the region in the problem here? What is the region given? Okay. What is R? Well, R, what are the limits of x? X between age and age, x between 1 minus 1 over 4, 1 minus y over 4, and x equals 1. Okay. What about y? The y interval. dy will go with 0 to 4. So it is the y interval, 0 to 4. Okay, 0 to 4. This is the outer y interval. Okay. Now describe the region. Sketch the region. And this is what you have here. The R. So this is x and this is y. The y interval from 0 to 4. So this is 0 and this is 4. What about the x interval? Will be a curve. This is left curve and right curve. Left curve معناتها left curve تكون x equals 1 minus y over 4. Right curve, x equals 1. اوكي، فx equals this حيكون the left curve and x equals 1 حتكون the right curve. You graph them. Okay. This is a line. So when y equals 4, this becomes 0. So this is h, the pointing. When y equals 0, you get x equals 1. So this is h1. This is 1. Okay. But this is h, the first line. This is the first line. So this is x equals 1 minus x equals 1 minus y over 4. The right curve x equals 1. This is the line x equals 1. So this is x equals 1. Okay. This is the left curve and this is the right curve. The interval from 0 to 4. So I have to stop here. This is h stop. Okay. So this is h, the region. This is the region. This is our region R. Okay. This is the region R. Okay. Notice we didn't take this one. This is the one because this is the left. When you take at the point here y, you take this is the left and this is the right. X equals the line 1 minus 1 over y over 4. This is the left curve. X equals 1, the right curve. So this is h, the region. This is the region, left and right. What we do here when we say reverse, we mean take the same region. Okay, take the same region. Okay. So I will take it again. Okay, so this is 4. This is 4 and this is 1 and this is h. This is h1 and this is the line here. Okay, and this is the region here. Okay. What I will do is the following. Now I will take, instead of taking the outer to be the y interval, I will take the outer to be the x interval. Okay. And R, the same region, but describe it in a different way. Outer هتكون x interval. What is the x interval here for this region? 0 to 1. So this is 0 and this is h1. So x between 0 and 1. What is the inner? Now we take a vertical line. In the direction of the y-axis. Okay. I need y, the limits of y. So I go in the direction of y, a vertical line at arbitrary x here. And I enter through this line and I leave it through this line. Okay. What is the equation of this line? Okay. What is the equation of this horizontal line? This is the outer curve. This is the outer, the upper curve. Okay. It is the horizontal line. Y equals 4. Y equals 4. What about this line here? This line, okay. It is the same as the previous line. X equals 1 minus y over 4. But I have to write it in terms of y as a function of x. So this becomes y over 4 equals 1 minus x. So y equals 4 minus 4x. Okay. So the lower هتكون y equals 4 minus 4x. So I write 4 minus 4x. The upper y equals 4. Y equals 4. Okay. This is h now. So now I write I am having the same region. It is the same, but I describe it in a different way. So now the original integral, which is 0 to 4, 1 minus y over 4 to 1, e power x squared dx dy. This is the original integral. Okay, now I reverse. Yani type 2. This is type 2. Type 2. This is h type 2 equals h equals the new integral type 1 e power x squared dy dx. The outer is the x interval 0 to 1. The inner is the y interval 4 minus 4x 2 to 4. This is what we mean by reverse. Okay, this is what we mean by reverse. So reverse, it means write it from type 2 to type 1 or type 1 to type 2. Now integrate. Now integration is easy, okay, because هنا الآن integrate e power x squared dy. Integrating with respect to y, x is constant, so this is constant. So this becomes e power x squared times y, okay, from y equals 4 minus 4x to y equals 4. This is h. Now when you reverse, integration becomes easy. And integrating this with respect to x is not possible, but integrating e power x equal with respect to y is very easy. Okay, just a constant times y. Okay. Now just substitute. What do you get here? This becomes e power x squared. هتكون ايش 4 minus x. Okay, and this becomes e power x squared, e power x squared times 4x times 4x times 4x. Okay, so this is the value of the inner integral. Okay, this is the value of the inner integral. Now bring the outer integral. So this is 0 to y dy upon dx equal 0 to 1, 0 to 1 dx equals 0 to 1 times dx dx. Okay. Now this is h. Just use your substitution. This is very simple. So this becomes an h 2 e power x squared from 0 to 1. Okay. Okay. When you substitute, what do you get? You get h2 e minus 1. Okay. This is the idea of the subproblem. So this is really a tricky. This is a tricky thing, but it is not difficult. So basically, if you cannot integrate, just reverse the order of integration. And this means what? Well, write it as an integral. If it is of type 2, make it type 1. If it is type 1, make it type 2. Or look at the outer limits. From 0 to 4, it is a y interval. So write it as an integral with outer integral as an x interval. And instead of 0 interval, take it as x interval. And as I said in the class, almost all regions that you will deal with can be described with the outer as x interval or the y interval, i.e. we can describe them as type 1 or type 2. Okay. So this is the tricky question that I mentioned in the class. It is very important. Make sure you understand it. It appears in every quiz and it appears in every final exam. يعني in a final exam, expect a problem similar to this one. Okay. Again, so let me give you another example. Just so. Okay, this is another example here. Evaluate this double integral. Again, when you start evaluating integral of 1 over y power 4 plus 1 dy, we cannot integrate it. Okay. Think about it. Try. Okay. You will see it is you cannot integrate. Can't integrate. معناته what do you do? Reverse. معناته type 1 to type 2 or type 2 to type 1. Outer interval, x interval to y interval or y interval to x interval. So here, what is our region? What is the region here? This is the region. We have the outer 0 to 8. They are the x interval. So this is the x interval. So this x between 0 and 8. This is the outer x interval. So I get it from the integral. What are the limits of y? The inner y بإيش؟ y هتكون cube root of x to 2. Limits of y cube root of x to 2. Okay. Sketch it. Sketch this region here. And this is the sketch here. The x interval 0 to 8. So this is 0 to 8. Y interval معناتها y equals the cube root of x This is the outer, y equals 2. This is the y equals the cube root of x is the lower curve, y equals 2 is the upper curve. So y equals 2, let me say this is 2, y equals 2. Y equals the cube root of x, this is h cube root of x, okay, this is h cube root of x, and this is cube root of x. Okay, and just let me say this is 8 here, just make it okay. Okay. What is the region? Okay, the region. طبعا هنا notice هنا this is the point of intersection. At 8 you get 2. At 8 you get 2. Okay. What is the region? This is the region here. This is the region. It is not the one here. It is not the one. Why? Because what is the lower curve? Y equals the cube root. What is the upper curve? Y equals 2. So it has to be here. This is the lower. This is the upper. So if I take here x and you go in the y direction, this is the lower cube root of x. This is the upper. Y equals 2. Okay. Now I will write it so that the outer will be the y. I will work on the y interval. Okay. So we take the same region here. We take the same region here as it is. But this is let me say this is 8 and this is 2. Okay. And this is the same region here. This is the same region. And this is y equals cube root of x, and this is x equals 8. Okay. Now I want to take the outer to be the y interval. So what is the y interval of this region? 0 to 2, 0 to 2. This is the y interval. So y between 0 and 2. Then I need to take left and right. So I take horizontal line. I need x, okay? So this is at certain y. I need to know what is the left and what is the right curve. I am entering through H, the y-axis. The graph of the y-axis is x equal to 0. This is the inner. What is the left curve? What is the right curve? This is the right curve. I have to solve it for x. So this implies x equals y cubed. So what x will go from 0 to y cubed. X will be the left curve, x equal to 0. 0. The right curve, x equals y cubed. Y cubed. Okay. So you describe it as you describe it just as so that the or the outer interval is a y interval. So now the double integral from 0 to 8 cube root of x to 1 over y power 4 plus 1 dy dx. This is the original. Now equals double integral 1 over y power 4 plus 1. Now dx dy. Okay. You switch. What are the limits? What is the y interval? 0 to 2. 0 to 2. This is 0 to 2. What is the x? هتكون from x equal to 0 to x equals y cubed. 0 to y cubed. Now I integrate. When you integrate this, okay, now this is a function of y. We integrate with respect to x. This is constant. So هتكون 1 over y power 4 plus 1. What is integral of 1 dx? هتكون just x. From x equal to 0 to x equals y cubed. This becomes 1 over 1. طبعا this is x. هتكون 1 over y power 4 plus 1. And this is y cubed minus 0. So this is y cubed over y power 4 plus 1. This is the value of the inner integral. Bring the outer integral. This becomes 0 to 2 dy. And I make u substitution. And let u equals y power 4 plus 1. Okay. And then the derivative will be 4y cubed. Okay. When you make a U substitution, you get the following: 1/4 ln y power 4 plus 1 from 0 to 2. Okay. A simple U substitution. Okay. Substitute, you get h 1/4 ln 70 minus ln 1. But ln 1 equal to 0. So this is h 1/4 ln 70. Okay. This is the trick that I mentioned in the book. And make sure it is clear. Just try to understand and make a practice. And if you have a question, you can come and ask. Okay. Okay. That's it. Have a nice day. Have a nice day.